Okay, we are going to simplify radical expressions. And there are a few things that we need to be reminded here first before we get going, and that is about square roots. Remember that x squared, if we take the square root of x squared, that equals x, which means the square root of 3 squared is going to equal 3, because 3 squared is 9, and we all know the square root of 9 equals 3. Also, if you have many numbers under a radical, you can separate them, or if you have separated numbers under a radical, you can multiply them and put them under one radical. Also, if you have something that looks like this, like a big fraction, you can separate those too and do the numerator and the denominator separately. Now, the key to simplifying radical expressions is in knowing and finding perfect squares or pairs of numbers. So if we look at these perfect squares, if we see those in a problem, then that makes our life an awful lot easier. So it's really great if we know those. If we can break something down to a 4, a 9, a 16, those are easy to deal with. Otherwise, we have to break them down into primes, and that would be 2 times 2, or 3s, or 4s. 4 is not a prime, but it is a perfect square because the square root of 16 is 4. But we're looking for pairs of numbers. For example, if we break the square root of 4 down into 2 times 2, that means we can, out from under the radical, that's going to be a 2. If we have 2 3s, then we can pull out a 3. If we have 2 4s, we can pull out a 4, 2 5s, a 5, etc. Makes our life a lot easier if we can recognize that we are looking for pairs with square roots. So let's try one here. I'll do one with pairs. That's this one right here. We have the square root of 68. Well, 68 is 2 times 34. We want to keep breaking it down. We have no pairs. So 34 can be broken down into 2 times 17. Now we happen to have 2 2's. Hooray! So we can pull a 2 out from under the radical because the square root of 4 is 2. And the 17, sorry, there's nothing we can do about that. It just has to stay under the radical. So our answer then is 2 times the square root of 17. Now, if we recognize perfect squares, we can see that we can break down 68 into 4 times 17, 4 being the perfect square, which means we know the square root of 4 is 2, so we can pull the 2 out from under the radical, and the 17 stays there. So you'll notice that if you can recognize your perfect squares and pull them out, then that makes your problem a lot less complicated. So if you know your perfect squares, again, you should know and be able to recognize your perfect squares. Let's look at this one. 5 times the square root of 200. There are a number of places where we can make our life simpler. Let's see what we come up with. Probably most people will look at 200 and say, oh, well, I know that 200 is 2 times 100. Excellent. Now, if you recognize your perfect squares, you'll make your job a lot easier if you recognize that 100 is a perfect square. Square root of 100 is 10. So then we could pull a 10 out and we end up with 50 times the square root of 2. However, if we don't recognize that, we have to break 100 down to 2 times 50. So now I have the original 2 and a 2 times 50. Nothing we can do there. We do have a pair though. We're recognizing that. We have to keep going. Let's break 50 down to 2 times 25. 25 is also a perfect square. So if we recognize that, we could make our life simpler again by saying, oh, I know the square root of 25 is 5, and pulling that out from under the radical. If we don't, however, recognize that, we have to keep breaking it down, and we know that 25 breaks down to 5 times 5. So now, when we look at what we've got all prime numbers here. That's as far as we can go. So we're looking for our pairs. We've got a pair of 2's and a pair of 5's. That means that we can pull out a 2, and these go away, and we can pull out a 5, and these go away. So what's left in the radical or under the radical is a 2, and what's outside is our original 5 and our new 5 and a 2. So 2 times 5 times 5 happens to be 50 times the square root of 2 is our answer. Now here we have one that is in fraction form. So we're going to separate square root of 148 over square root of 36. Now if we are wise, we recognize that 36 is a perfect square. It is 6. So then we have to deal with our numerator, and that's the square root of 148. When I look at that, the only thing that comes to mind is that it can be divided by 2 because it's even. So it ends up being 2 times 74. 74 also being even means that I can divide 2 into that again. And I end up with 2 times 2 times 37. And thank goodness I have a pair of 2's here, so I can pull a 2 out from under the radical. And the 37 has to stay in there. So that is very convenient. So now we have 2 times the square root of 37 over 6. We are not done yet because we have a 2 over a 6, which is a fraction that can be reduced to 1 over 3. Now, remember that that 1 here can just be, you can put it in there, but typically we don't. Typically when there's a 1, it's just square root of 37 times 1. It just stays the same. So we're just going to leave it as a square root of 37 over 3, and that's our final answer. Now let's talk about cube roots. Cube roots are when we have 3 under the radical. So x to the third, the cube root of x to the third is going to equal x. The cube root of 4 to the third is going to equal 4. And the key for this is knowing and finding perfect cubes or triples of numbers. That would be like this. 2 times 2 times 2 is 8. So the cube root of 8 is 2. And we've got the cube root of 27. It's going to be 3 times 3 times 3. So we've got a triple there. The cube root of 27 is 3. And so forth. If we have the cube root of 64, it's going to be 4. The cube root of 125 is going to be 5. The cube root of 216, I believe, is going to be 6, because it's going to be 6 times 6 times 6. These are very, very simple to get to know, and it's very good if you can actually learn what the most popular, which are the smallest, of these are. They are the most used because they are the smallest. Now, let's look at fourth roots and fifth roots. If we have the fourth root of 16, we need 4 numbers that are multiplied together to get us 16, and that is going to be 4 2's, which means the fourth root of 16 is 2. If we have the fifth root of 243, we're looking for 5 numbers multiplied together that give us 243, and that happens to be 5 3's, so the fifth root of 243 is 3. Now let's try this. We've got the cube root of 200 and our 5. We did this with square roots last time. So we are going to start in the same place, and we're going to say, all right, the cube root of 5 times the cube root of 200. Well, 200 is 2 times 100. We have nothing we can do there. We know that 100 is a square, but is not a perfect cube. So we'll keep going. 100 breaks down to 2 times 150, or 2 times 50. And 50 breaks down to 2 times 25. We have 3 2's here. That's good. But we know that 25 will break down into 5 times 5. Well, that's not going to help us with our answer because we need 3's. But we do happen to have 3 2's, which means we can pull a 2 out from under the radical. And when we do that, we end up with 2 times 5 outside, and our 5 times 5 just has to stay inside. So 2 times 5 is 10, and our square root of 25, 5 times our cube root of 25 has to just stay inside. So this is our final answer. We cannot break down the cube root of 25. Your turn. Here are 3 problems. So you can pause the video and then make sure that you try everything that you can, get down as far as you can, and check the answers on the next slide. Pause now. Okay, here are the answers. We have the square root of 90. We end up with a pair of 3's, so we can pull a 3 out, and we are left with 10 in the radical. Here we are looking for cube roots. We already know that the cube root of 8 is 2. So here we have 3 2's on the top. And looking for 128, look at all these groups of 2's. So if we need groups of 3, we end up with 2 groups of 2's that we can pull out. So it's 2 over 4, or 1/2. Here we have the 4th root of 243. And we are looking for a bunch of 3's here. We end up with 1, 2, 3, 4, 5 3's. So 1 3 has to stay under the radical. And we can take these 4 out. We end up with 3 times 5. Remember, we need 4 in order to pull it out from under the radical. So we end up with 3 times 5 is 15 times the 4th root of 3. It's the best we can do. All right, we'll see you in class.